Hello dear students, today we are going to talk about PN junction diode as a full wave rectifier. Uh, this topic we are going to read through PowerPoint presentation, so I'm going to share it now. So let us have a look through slideshow. Yes, here it is. Let us discuss the topic. PN junction diode is a full wave rectifier. As we all of us know that a PN diode is a two-terminal device having P-type semiconductor device and N-type semiconductor device fused together. And the PN junction diode can be used as a full wave rectifier, and the working of PN junction diode as a full wave rectifier is explained using the following diagram can be explained. It consists of a step down transformer. It is the primary coil of step down transformer, and it is the secondary coil of step down transformer. The PN diodes, we take two PN junction diodes so that it can work as a full wave rectifier. The P region of the diode is connected to the secondary coil of the transformer, and the N region is connected at a point. The common point is again connected to the central tapped region of the transformer through load resistance RL. Now, when a positive half cycle appears across the secondary of the transformer, when we supply AC voltage to the primary coil, the secondary coil, the AC also appears across the secondary coil, and during positive half cycle, this point will be at higher potential with respect to this point. So let us consider this point is positive part and this point is negative part. During the positive half cycle, the P region of diode D1 is connected to the positive potential, whereas the P region of diode D2 is connected to the negative potential. So the diode D1 is forward biased when P region of any diode is connected to positive potential, then it will be forward biased, and when P region is connected to negative potential, then it will be reverse biased. So diode D1 is forward biased, whereas diode D2 is reverse biased. Now when current passes through this region, since diode D1 is forward biased, so it conducts the electric current, whereas diode D2 do not conduct the electric current as it is reverse biased. So the current passes through the diode D1 and through the load resistance RL, completing the circuit. So the positive half cycle of AC input also appear across the load resistance RL, and the output is taken across the load resistance RL. So the positive half cycle of AC input appears as the output. Now, when after a certain time period, uh, the polarity of the AC input changes. So, let us suppose this point becomes negative potential with respect to this point. So, now this is a negative potential, whereas this point is a positive potential. Now, the diode D1 will be reverse biased as the P region is connected to the negative terminal, whereas the diode D2 will be forward biased as the P region is connected to the positive terminal. That is, the diode D1 does not conduct the electric current, whereas the diode D2 conducts the electric current. So during half cycle of uh, AC input, during negative half cycle of AC input, the this point will be a negative potential and this point will be a positive potential. So the current passes through diode D2 and through load resistance RL in the same direction as shown in the figure. So during positive half cycle also the current passes to load resistance RL in the direction from direction B to A, and also during the negative half cycle the current is passed to the load resistance RL in the same direction B to A. So both half cycles, positive half cycle or negative half cycles, appears is the output voltage, but in the the direction is unidirectional, that is from B to A. In both half cycle the direction of current is from B to A, so the output has unidirectional property, so it is shown in the is a positive half cycle. So both half cycles of AC input is converted to uh, output. So it acts as a full wave rectifier. And since both half cycles appear in the same direction, so uh, it is DC. Although the output waveform is slightly fluctuating, but since the direction is from B to A in both cycle, so it is a DC, pulsating DC current. Here, this yellow region represents the rectified portion due to diode D1, whereas the green part represents the rectified portion due to diode D2. Hence, the AC input is rectified is a DC full wave DC output. Thus, the rectifier using two diodes D1 and D2 acts as a full wave rectifier. Thank you.